So first things first, let's make sure all phones are securely away, not in your pocket or on your table, so that you don't get distracted by them. In a bag below, floor below, chair next to you, etc. etc. Okay. All right. So today we are going to be performing operations with complex numbers. Okay? And so we're going to solve problems containing complex numbers, because what we want to do is we want to be able to find all of the zeros of a polynomial function. Not just like pick out the imaginary ones, again, like we have been doing up to this point in time. Okay? We want to be able to find them all. Okay? So in order to do that, we got to take a break. We got to pause for the cause, and we've got to back ourselves up to Algebra 2. Okay? So we're going to go back to Algebra 2 here for a minute. Okay? So back in Algebra 2, we had something that looked like this, the square root of negative 8. And when we had the square root of negative 8, we said, whoa, 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 tap the brakes. Okay. We said this can't happen in the real world. It can only happen in the imaginary world. Okay? Because if we have a square root, we're looking for two numbers that can multiply together to be that number. And if it's the same number, it's just not going to work out. It doesn't work out to get a negative number. Because a negative times a negative is a positive. Positive times a positive is a positive. So it just doesn't work out. So then we talked about, or then you talked about I, and how I was a special variable in the world of mathematics, and how I was equal to the square root of negative 1. And how I squared is equal to just negative. So you talked about those two facts along with that. And that allowed you, by knowing those two classifications right there, that allowed you, back when you were in Algebra 2, it allowed you to solve a polynomial that looked like that. And you guys did quadratics when you were in Algebra 2. It allows you to solve that. Okay? Because solutions to polynomials are places that it crosses the x-axis. And that polynomial, that purple polynomial, doesn't cross at all. Okay? And so it would be like, oh, we can't solve it, we can't do anything with it. Well, now with imaginary numbers in our toolbox, that we can do that. And how we use it and how you used it back then is we'll bring back the square root of negative 8 here. You would say first that that is equal to the square root of negative 1 times the square root of 8. And then you would say something along the lines of, well, that is equal to the square root of negative 1 times the square root of 4 times the square root of 2. Because 4 is a perfect square factor. So we're going to also be simplifying radicals today, which is another topic that you learned way back in Algebra 2 and geometry and in Algebra 1 and all those fun times. Okay? And then we would say here that the square root of negative 1 is I, the square root of 4 is 2, and the square root of 2 is just the square root of 2. And since we're multiplying all of those together, we could say then here that the square root of negative 8 is really 2I times the square root of 2. So then in life, there's these number things. Okay? So really in the maths, there's three kinds of numbers. There's real numbers, there's imaginary numbers, and there's complex numbers. Okay? Then there's also irrational and all of that stuff. But for us right now, three kinds of numbers. So a complex number is a combination of a real number and an imaginary number. So a complex number has a real part, which is some kind of a number, and it's got an imaginary part, which has an I attached to it. Now, we can take any old number. For instance, so a regular old complex number would look like 3 plus 2i. Okay? Where, let me scroll back up here a little bit. Where 3 then is the real part of the complex number, and 2i is the imaginary part of the complex number. But I can make that be any number. So like I could say here, come on now, come up 3, there you go. For the real number, like 6. Okay? I can write 6 as a complex number by saying that that's 6 plus 0i. I can take any imaginary number, like let's say 2i, and I can make that be a complex number by saying that that's 0 plus 2i. So really, if you just have like 7i, 7i is an imaginary number. 0 plus 7i is a complex number. They're the exact same thing, it's just written in a different form. Let's put it to work. Let's go to work. Okay. So, I would like you to simplify the following two examples. All right. So, square root of 49 is going to be the square root of -1 times the square root of 49. Right? What's the square root of 49? 7. What's the square root of -1? I. So this is just 7i. Questions, comments, concerns?
So it's 7i, not 7 plus I.
Nope, 7 times I. Because all we're doing is multiplying. 2 times the square root of -1 times the square root of 32. So that's going to be 2 times the square root of -1 times the square root of 16 times the square root of 2. Because 32 is 16 times 2, and 16 is a bigger perfect square than 4. If you would have done this as 4 times 8, that's great and all, but then you got to realize that 8 has another 4 in it. So you got to do 2 square roots of 4. There. Okay? That is wrong. Because outside numbers don't mix with inside numbers. Yep. So this 2 just comes along for the ride. Square root of negative 1 is I. Square root of 16 is 4. And the square root of 2 is the square root of 2. Still multiplying them all. 2 times I is 2I. Times 4 is 8I. So this is 8I times the square root of 2. Questions, comments, concerns, clarifications. I'll even take complaints.
I just don't think
Because 16 is the biggest perfect square factor of 32. 16 times 2 is 32. Perfect square is 1, 4, 9, 16, 25. Okay. I don't think that there's any more down here. There is not. So we go to the next slide. Try these two. So the first one would be 10 times the square root of negative 1 times the square root of 28. The square root of 28 would be the square root of 4 and the square root of 7. So 10 is 10. Square root of negative 1 is I. Square root of 4 is 2. Square root of 7 is the square root of 7. 10 times I is 10I. Times 2 is 20I. Times the square root of 7 is 20I times the square root of 7. Who was right?
I was.
All right. Next one, negative 4 times the square root of negative 1 times the square root of 75, which would be negative 4 times the square root of negative 1 times the square root of 25 times the square root of 3. Negative 4 is negative 4. Square root of negative 1 is I. Square root of 25 is 5. Square root of 3 is the square root of 3. Negative 4 times I is negative 4I. Times 5 is negative 20I. Times square root of 3 is negative 20I. Bad I. Bad I. I times the square root of 3.
Good job, Mr. Whistler.
Thank you.
Okay.
Did you get a good job too?
I said,
Good job. Okay. I don't think that there's any more on this slide. And we're done with this slide. Okay.
ooh.
Ooh. So now I want to solve this quadratic equation. Okay. So the first step in solving the equation is what? Nope, that's right. Set it equal to 0. Sorry, I was in the middle of a drink, so I couldn't say yes.
Okay.
Okay. So set it equal to 0. Done, not done? Done. Love it. Okay. So then, because we don't have a linear term here, we can do this one a different way. And I haven't shown you this method yet, but it works when you just have a squared and a number. Okay. And some of you already picked up on it. I saw a few of them on last week's homework, etc., etc., etc. But we're just going to subtract 6 here from both sides. That's going to give me x squared equals negative 6. Makes sense. Now we're going to square root both sides. Okay. The square root of x squared is x. Okay, I like that. But then we got the square root of negative 6, right? Okay. But how many answers do I need to get in this problem? Why 2? because my exponent is 2. So I gotta have 2. So what do I need? Because we're taking a square root and we're solving. We needed plus or minus in there. Yep. Yep. Anytime we take, and that's where a lot of people made mistakes last week, is they forgot the plus or minus on that one. Okay? So this is plus or minus the square root of -6. Now I don't like the square root of -6. So what is the square root of -6? Simplify. No. Okay, are there any perfect square factors that go into 6? 2 is not perfect. 1, but that's it, right? So it's just going to be I times the square root of 6, right? Okay, so then that would be our answer. That would be the simplified version. X here is going to equal plus or minus I times the square root of 6. And there's my 2 answers. Now, if you chose to write them separately, that's your choice. You can just write it as plus or minus. Okay? Oh. Ouch, Townlands. Making us do examples. Oh, I heard it. Miss Jenna Ray. Elijah, I'm sorry that you had to be abused for my example. First step.
That equals 0.
That equals 0, right? Now, do we want to move everything left or do we want to move everything right? Left, right? Yeah, let's go left because then we got positives. Yeah. So I'm going to subtract 4x and I'm going to add 4 at the same time. So that's going to give me x squared minus 4x plus 13 equals 0. Yes? Can I factor? No. Two numbers that multiply together to be positive 13 and they had to be negative 4. Only ones I know of are 1 and 13 and they don't have to be 4. Okay? So what do we got left? What? Can I subtract 13 and square root both sides? You think so? Maybe? You tell me. Because I said it already. Because there's that 4x term in there. If there wasn't that 4x term, yes, we could. Okay? But that 4x term says, can't do it that way. 2x squared minus 8x plus 26 is still not factorable.
Right, so if you made it like, somehow made it squared, and you combine the two.
But I can't, because I can't combine them at all because there's no way I can make just one term squared. Because I got to do, whatever I do, I got to do to all of my terms.
So if you add it on the right side.
You're missing the obvious one. We got to solve it. It says so right there. Solve the equation. We got to get answers. What you got, Raina? Quadratic formula. Yep. Yep. Quadratic formula.
You guys are really pushing this podcast.
So, do you have it memorized yet?
No.
You probably should if I've been pushing it for the last couple of
You
days.
should sing this song.
Yep. 2A. 2A.
Well, that's just the end.
I know. That's the only part that I like. Okay? Alright? So then we gotta go in, we gotta do this now. Alright, let's do this. So we've got x here is going to be equal to the opposite of -4 plus or minus the square root of -4 squared minus 4 times 1 times 13 all over 2 times 1. Agree with me on that. Give you a moment to let that sink in. Good all around? Opposite of -4. 4. -4 squared. -4 squared. 16.
Oh, that's my back.
-4 times -4 is 16. 4 times 1 times 13. 52. 52. I always remember that one because there's 4 suits in the deck of cards, and each suit has 13 cards in it, and there's 52 cards in the deck of cards. Right? 16 minus 52. 36, isn't it? -36. Do I like the square root of -36? No, what do I like instead? What?
5 times the square root of 36.
And what's the square root of 36? 6. So what do I like instead?
6i.
6i. Yep. Do I like that as my final answer? No, why not? Because I can all of my numbers can be divided by 2. And all of the numbers are outside. Okay? So 4 can be divided by 2. 6 can be divided by 2. And 2 can be divided by 2. Okay? So I like instead, as my final answer, I like x is equal to 2 plus or minus 3i. Now, had there been a radical there, that would be protected because the radical is in control. Okay, so we can't divide into the radical. Good? Good times.